Alright, this is number 19 from the T3 review, bank curves with friction. So we're given a radius of 70 meters, a mass of 1500 kilograms, and an angle of the bank curve of 15 degrees. So basically what we're trying to do here is find the maximum velocity on the bank curve. So what it means by maximum velocity is how fast can the car go without sliding upwards, right? Because if you have enough speed, you can break out of the bank curve and then go up and up and up and eventually leave it. It's kind of like how in in the universe, right? You have orbits. So like everything orbits like the sun, right? Say if like you're trying to find like a speed where the maximum speed of like the Earth in orbit. So basically you're trying to find the speed it goes without breaking the orbit, because anything faster than that it'll just go farther and farther away from the circle instead of getting sucked inwards. So what I want to do first is draw a free body diagram. So our force normal would be this way, right? And then force of gravity would be this way. So when we're drawing a bank curve, it'll be like this, right? And this is our car. So basically what I was saying about how fast can it go without escaping the bank curve, it would have to go upwards, right? Because if it would go, or at least not upwards, but like it'll go this way. If it were to go this way, then it'll just get sucked in, which is not the point here. We're trying to break out of the bank curve. So because velocity, the direction of motion is trying to go this way, friction will just be the opposite direction, so it'll be this way. So here we go. And these aren't just straight lines. I mean, the force of gravity is, but normal force and friction have seem to be angled. So that means they have components. So we have normal here. So it would have an NX and an NY. And then friction would have a FX and an FY. So for the components, I don't really have an exact answer to derive this, but just know that NX is N sine theta, and then NY is N cosine theta, and then for force friction X, it'll just be F cosine theta, and Fy will be F sine theta. So just the other way around. So like you go from sine to cosine and then cosine to sine when you're dealing with normal force and friction. So basically, to find the velocity max, we need this equation, right? Because this is technically in a circle. So we need this equation. Mass times the centripetal acceleration, which is velocity squared over radius. So the direction of the centripetal force would be this way, right? Because you're trying to like maintain your vertical position, so it wouldn't be any higher or lower. Then you would just eventually go up and up and up. But if you're trying to maintain like this kind of position throughout the whole thing, because think about it, it's more of like a spear, you know, like a whirlpool. So it would have to be like horizontally to the right or left. So let's look at our components a little bit deeper. So we see that NX and FX are in the same direction, and they're both right, and the centripetal force is going right. So we could say that NX plus FX equals mv squared over r, or n sine theta plus f cosine theta equals mv squared over r. Now for the case of normal force and friction, since they don't give us a specific coefficient of friction, we just assume that there's as much friction as possible. For in that case, the coefficient of friction would be 1. So if we get the equation for force of friction, it would be friction equals normal force times mu, right? And since this is 1, the force of friction would just equal n. So we could just cross that out. So you can just like make this n right here. So then you don't have to worry about like calculating the coefficient of friction because it's already given. So we can do this the same for the y. So we can set up equation for the y direction now. So then we can get a system of equations that we can solve for v. So then we see that normal force y is going up, friction force y is going down, and mg is going down. So that means in order to maintain its vertical position, these two have to equal ny. So it had to be ny equals mg plus fy, or in this case it would be n cosine theta equals mg plus f sine theta, or in this case it would be n because coefficient of friction is 1. Now we have our two sets of systems of equations. So now all we have to do is just solve for v. But so look at what we're given. So we're given r, m, and theta. So if we look at these equations, and also g as well, that would be 9.8, but we already know that. Meters per second squared. So what we don't have is n and v. So what we can do here is that we can try to find n and then sub it into the other equation. So what we can do is isolate n. So what we can do is we could take this to this side and then factor out. So I'm just going to do some quick maths here. Right, because you subtract this, that'll be n cosine theta minus n sine theta, and then you can factor out. God damn. Stop sliding. Alright. So then you can just easily solve for n in terms of stuff that we're given. So it'd be hold on. What the fuck, man? Sorry about that. So that'd be n equals mg. Hold on. Alright, sorry about that. Alright, so mg over cosine theta minus sine theta. So now that we know n, we can plug it into this equation right here, and then basically with all the given information we can find v, right? So I'll just continue it on the back page. So n sine theta plus n cosine theta equals mv squared over r, right? So it's just this equation right here. And we're given that n equals mg over cosine theta minus sine theta from the previous derivation. So what we can do is say mg cosine theta minus sine theta times cosine theta plus mg over cosine theta minus sine theta times cosine theta, right? Because we're just subbing in n for this to equal mv squared over r. Because these have the same denominator, we could just add these up. No problem. We don't have to like add anything to any side. And also we see here that mg can be factored out in the numerator, so we could just do that. So sine theta plus cosine theta and then what we could do is multiply by r over m on both sides. I mean, you could do multiply r then divide by m, but I mean, we can make things go fast, a little bit faster if we do rm on both sides. And then we see here that the masses cancel out. So you just get rg times sine theta plus cosine theta over cosine theta minus sine theta equals v squared. And then you just take the square root of that. And then that'll give you your V max. So with the given information back here, we can easily calculate this. Just be careful with your, like, if you're using the WebWork calculator, then be careful on your parentheses. So you could do 70 times 9.8 cosine 15 minus sine 15 over cosine 15 minus sine 15 all under the square root equals V max. If you're using WebWork calculator, remember to convert this to radians because they don't accept degrees. So when you put that all in the graphing calculator, WebWork calculator, you should get a V max of 34.5 meters per second. And that's it.